The search for extraterrestrial intelligence represents humanity's quest to find signs of life beyond Earth.
In the case of SETI, it's perfect to study non-human intelligences on Earth. Why not practice?
If you're curious about SETI or ever wondered what a whale might have in common with an alien, you've come to the right place. Welcome to Whales and Aliens, the search for extraterrestrial intelligence in the Salish Sea. I'm your host, Lisa Walker. The Salish Sea, nestled between British Columbia and Washington State, is one of the most biologically rich marine ecosystems on Earth. It's also a living laboratory for studying non-human minds. From the songs of humpback whales to the complex social behaviors of orcas, the Salish Sea offers a rare opportunity to observe sophisticated communication in the wild, and its whales may hold clues to understanding intelligence beyond our species. Our aim is to connect the dots between animal cognition and the search for extraterrestrial intelligence, SETI. If we can learn to decode the minds around us, we may be better prepared to recognize intelligence when it calls from beyond. Intelligence refers to the ability to acquire, understand, and apply knowledge and skills effectively. It involves various cognitive functions such as reasoning, problem-solving, learning, perception, and adaptation to new situations. While SETI is often described as the search for extraterrestrial intelligence, in practice, it's more accurately the search for extraterrestrial technology, as intelligence alone doesn't leave a detectable trace across interstellar distances, but technology might. Specifically, SETI has traditionally scanned the skies for narrowband signals, those less than 1 Hz wide, a type of signal not found in natural astrophysical process and often considered a potential hallmark of extraterrestrial intelligence. In this podcast, we are going to explore how the search has expanded from narrowband signal detection to the broader search for meaningful communication. In today's podcast, I'm thrilled to be joined by Dr. Laurance Doyle, an astrophysicist whose work at the SETI Institute is reshaping how we think about intelligence, communication, and the search for life beyond Earth. Dr. Doyle was one of the earliest scientists at the SETI Institute, joining shortly after its founding in 1984. With a deep curiosity of the cosmos, Dr. Doyle has played a key role in broadening SETI Institute's scope, from detecting radio signals to exploring potential alien intelligence through the lens of animal communication. His contributions inspire new generations of scientists seeking to understand humanity's place in the universe.
When I was 6, my dad gave me a map of the solar system with stars in the background. And he said that the stars were other people's suns. Whoa. So the people say, how'd you get hooked on astronomy? I was an astronomy major all through junior college, high school, etc. And it was because of, they say, when did it start? And I can remember distinctly leaving the Earth when Dad said the stars are other people's suns. So I guess my first interest in astronomy was SETI, in a way, because other people's suns imply that there's intelligent life out there. The search for extraterrestrial technology has been going on now for about 60, 65 years. But it's time for a bit of a new paradigm for one particular reason. It turns out that a whole bunch of planets have been discovered, 6,000 now and counting, that we didn't know about when SETI started. And planets come with magnetic fields, as we know, our Van Allen belts, and also Jupiter's magnetic field. And what that will do is spread out that initial narrowband carrier wave. So if you're in another solar system and you're transmitting, you are going to not have a 1 Hz wide signal. It's going to spread it out. That means if you're looking for a narrowband carrier wave rather than the message it's carrying, then you're going to miss it. So all this says that with the discovery by Kepler and others of other solar systems all over the place, it's encouraging for SETI, but it also says, hey, if the magnetic fields are going to broaden the bandpass, then using a narrow bandpass may be why we haven't detected anything so far. We propose looking at the message and saying, is it an intelligent message? Well, now there's where information theory comes in. Information theory can measure the complexity of a message. And by complexity, we mean rules within the message that indicate structure. That in human languages we call syntax, grammar, and so on. So information theory is a proxy for, studying all the critters on Earth to generalize the rules of a complex communication, that when a signal is received at the Allen Telescope Array or some other radio telescope doing SETI, we can say, okay, let's look at it with things like information theory to see if it's complex enough to constitute a language. ET, if they are transmitting anything, then they have to obey, if they want knowledge to transfer, then they have to obey the rules of information theory. In other words, a lighthouse is very repetitive. Just blink, 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 blink. That is not going to be able to transmit information. Now, you could say, well, what about Morse code? Morse code is not blink, 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 blink. It's dot, dot, dash, dot, dash, dash, dot, dash, dash, dot. There's information in there. But we have to look at non-humans. Just looking at humans is looking for ourselves in the cosmos. It may be that the extraterrestrial intelligence is very alien. And I'll give you an example of a first order, probably the first intelligence filter would be obeying Zipf's law. A guy named George Zipf, Z-I-P-F, in the early 1950s, developed a way to spot a potentially intelligent signal. It's necessary but not sufficient condition, as we say in mathematics. Basically, he plotted the frequency of occurrence on logarithmic scale, doesn't matter, frequency of occurrence against the most frequent to least frequent. So on the x-axis is first, second, third, fourth, fifth. On the y-axis is, for English, the letter E, how frequently it occurs. The letter T, I think, is next. The letter A, and on down to the letter Q. And he drew a line through it, and it had a 45-degree -1 slope. So he thought, that's interesting. What if I do Chinese letters? And he did a book called Ulysses, had his students before word processors counting all the letters, bless their hearts. But they came up with this relationship for Chinese letters. So they looked at Russian phonemes, -1. They looked at conversations in Japanese, -1. Every human language obeys this rule. So then they looked at baby babbling, and it's got a slope of -0.4, somewhere around there. That's interesting. And then as the children learn their language, it goes up to minus 1.2 or so. Then it settles into minus 1. What is minus 1.2? That means they're getting repetitious. Grandma, 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 and then settle in. Some linguists were publishing papers saying that this law is the way to tell human communication from all other ones on Earth. Well, we had the last century or so, we got over ourselves being unique and separated physiologically or molecularly from all other animals. We even found that plants, because they make their own food and eat it, as opposed to us just eating, had more complex genetic structure. So basically, we encountered a prejudice against humans being like all other animals. So without testing, people were claiming this law is a uniquely human trait. But when we looked for this law with bottlenose dolphins, we discovered you get a minus 1 slope. So we were able to tell the linguistic community, hey, at least one other species obeys this law. I would say just one more thing. This law indicates but does not confirm that you have a language. So you then, if your communication obeys this law, then what you go looking for is syntax or conditional probabilities between the signals. And we found that for humpback whales. They actually have syntax. I'll give an example. I'm thinking of a letter, and it's the last letter of a word. So you may guess E. Well, you were being safe by guessing E. But if I say yes, then you say, okay, well, there's a word that ends in E. There's tens of thousands of those, so I'm not any better off. But I say, I'm thinking of a word, the first letter is, and you stick your neck out and say, Q. And I say, right. Well, now you've only got a couple hundred words to worry about. So uncertainty before measurement in information theory translates to more information. You were more uncertain of Q, but then you got more knowledge when I said yes. So uncertainty and information are on either sides of a mathematical measure called entropy. But it's not thermodynamic entropy, it's information entropy. So now, naturally, we want to go to humpback whales, because humpback whales, they are closer to extraterrestrials in several ways. The biggest one of which is that they don't care what people do. They show amusement, and they, come toward boats and blow bubble rings and things like that. But they don't, in general, you can't say, poke a button and we'll feed you, because they eat too much, for one thing. So as far as an extraterrestrial intelligence goes, humpback whales have a pristine communication system that we can study, and they also remain kind of unviolable. We can't really interfere with their culture, hopefully, or feed them or get them to do tricks or things like that. They're much more like ETI would be, I think. and they have a global communication system and so on. So we can measure most of the information they would put not into gestures or facials like humans or chimps. They put it into audio. Amazingly, to me, a non-biologist, that they should communicate in our range of hearing. And so in many ways, humpback whales are perfect as the principal species to feature in studying non-human intelligence for the purpose of coming up with intelligence filters. Yeah, I think that we always want to get to meaning. And I could take like von Frisch's work. He got a Nobel Prize for it. He figured out the bee waggle dance. And he had the measurements of the bees, waggling at a certain angle. And they have little muscles in their necks that indicate where up is vertical. And vertical is the sun. And the honey source, the bee would waggle at an angle, come around, waggle again, and take the same angle and make a kind of it would make a figure 8, but that angle was the angle to the honey source. The number of waggles was the distance, and the time they took to do it was how much the wind was blowing. So the elder bees would look and know how much honey to tank up on, and the younger bees would have to see the waggle dance 2 or 3 times, and even then they might go out and get lost. So it is apparently a learned process. But by knowing the purpose of the waggle dance, von Frisch figured out what it meant. So when you know the purpose of the communication, you can begin to get meaning, but you still need information theory. Humpback whales, when they're bubble netting, we know the purpose of the communication, and that's what's important for deciphering meaning. So at least the low-hanging fruit right now is that you measure the communication system and you measure the complexity of it. And if you know the meaning or the purpose, like for example, to make a bubble ring and get people to come, get your fellow colleagues to come up underneath and eat herring, then you can start to back out, the full context of the meaning of the communication. Reverse engineering is my favorite thing to do. It's my favorite thing because instead of a limitation, if you do it backward, I always think, what's the opposite? What's the backward thing to do when I come across a science problem? I love to do that. That's what I'm doing. Well, I think humpback whales are great for deprovincializing our thinking about intelligence. And I'd love to get everybody at SETI in a boat and get breathed on by a humpback whale. There's nothing like it to deprovincialize. After I got breathed on by a humpback whale for the first time, I asked myself, would the aliens be transmitting the value of pi or the golden ratio? No, they'd be talking about fish or whatever they talk about. But it's like, yes, the intelligence is undeniable, but it's also very alien. So I think we have to quit looking for ourselves in space. And we're going to learn a lot more about, intelligence in general than just human intelligence. I think it's important that we do this work. And it also gains respect for humpback whales. I think humpback whales express the same intelligence we do. I think intelligence, consciousness, and intelligence is a field, not a particle. That's what I'm learning from quantum physics. It's like, it's everywhere. It's a law of the universe. The model I like the best is that The intelligence is not in the humpback brain or in my brain or in our interacting brains. It's a field that needs to be discovered. So I feel like humpbacks, the Native Americans had it right. They're like brothers and sisters. And because we partake, not just because we should be friendly with them and things, but we partake of the same source of intelligence that the universe is imparting as a law. You know, it's like discovering the laws of physics, like Newton's laws and all. Where are Newton's laws? Well, you know, they're not like stuck in a bowling ball you drop from the Tower of Pisa or something. You know, it's like it's a law of the universe that is invisible, but nevertheless present everywhere. And I think laws of intelligence need still to be discovered because they are expressed in bees. And bees don't have a big brain. How in the world? They hardly have a nervous system. And humpback whales are really smart and they know things. And, you know, to me, it's like amazing that we can even like relate. It must be one sort. In other words, I'm advocating a law of the universe with regard to life and intelligence is still being discovered. Anthropologists say that we developed communication complexity to match our social complexity. So in some sense, if we're able to measure the entropic order, the highest entropic order of an extraterrestrial signal, we may be getting insight into the complexity of their society. We're going to know where we are in the communication hierarchy. What these all relate to is the Drake equation. Frank Drake came up with an agenda for a meeting in the 1960s, and he outlined the terms that relate to looking for extraterrestrial intelligence. And N is SETI, the search for extraterrestrial intelligence. N is the number of communicating civilizations in the galaxy. And that's equal to R sub star. Okay, have you got a nice star? Most stars are pretty habitable, have a habitable zone. Not pulsars, not exploding stars, and some are too variable. But most stars, I'd say 80% of the stars have a habitable zone. R sub star, next is F sub P, a fraction of star systems that have a habitable zone. Well, we didn't know that before Kepler. And the Kepler mission launched in 2009 and had a 4-year mission, and it discovered 5,000 extrasolar planets. So F sub P, the fraction of star systems that have a habitable zone that also have planets, turned out to be huge. It's not every star, but not every 2 stars. It's more like every 1.7 stars has a planet. That's hugely, encouraging to SETI. And about 11% of those are in the habitable zone and of Earth-ish size, super Earths. So that's encouraging. N sub B, how many have liquid water? Well, that's what James Webb Telescope's doing now. It's looking for the transit of planet in front of its star, and then you subtract when it goes behind. It goes in front, you add that, you subtract behind, and the star is shining through this little bitty atmosphere. But if the atmosphere has oxygen, like an ozone absorption feature, the thing about oxygen, for example, it's a biomarker, is that it's so reactive that it won't last in a planetary atmosphere unless it's replenished. Well, that means photosynthesis. That's how we replenish our oxygen. So if somebody were to detect free oxygen in a planetary atmosphere during a transit, which James Webb is built to do, I think we could announce that forests of whatever, seaweed, whatever, some kind of photosynthesis is going on out there. So that's N sub E, and F sub L. The next term is, okay, you develop an ecosystem. Does it have inhabitants? In other words, did biology actually happen? The next term is F sub I, and that's, did the biology become intelligent? And that's where we work. We call ourselves the F sub I group sometimes, but at SETI. And then there's F sub C. How many of intelligent species develop interstellar communication technology? And finally, L. And capital L stands for how long do such interstellar communicating civilizations last? And we go from knowing on the left side to complete ignorance on the right side. We're filling in F sub I right now. And F sub C, note, quantum is part of F sub C, as is Stonehenge, you can think of. And then L, we have no idea, but is politics. Well, there are three things about L, I would say. Get along with each other. Don't blow ourselves up. Get along with our environment. Don't get creamed by climate change, for example. And keep your technological head up so you can deflect a comet, which we recently tested on an asteroid, and it works. We can now do something the dinosaurs obviously couldn't do, or they would have. 3 criteria. We worked out the technical one. Getting along with each other and getting along with our environment. We're still working on that. But I think if we deflect the comet, I have vision that all the plants and animals will forgive us if we behave from now on. You deflected the comet, we'll call it even. It could be that we have a breakthrough, like when you study a language and suddenly it clicks. You're thinking in the language, you can say anything you want badly, but you can at least say it. It would be great to do that with humpback whales. So it's like, yes, the idea that we can sample other civilizations is to put ourselves in perspective. So this is all about, it's supposed to be about extraterrestrials and studying humpbacks, but we're also looking for ourselves. Where do we fit in? That's the big picture. Where do we fit in? And I think that's where most people's interest is, like, can I pet a humpback whale? Are we going to get an extraterrestrial signal? What do we do? It's like, where do we fit in the cosmos and in the ocean,
Dr. Doyle's groundbreaking work has helped shift SETI from a purely technological endeavor to a cross-species inquiry into cognition, culture, and meaning. His influence is now shaping a new generation of scientists, those who see the ocean as a proving ground for extraterrestrial contact, and who recognize that the search for alien minds begins with understanding the ones already among us. What an amazing conversation. Thank you so much, Laurance.
It was fun, Lisa. Thank you for inviting me and asking me to talk about my favorite things to talk about. It perks up my day.